Hello and welcome everyone. Our today's question is based on binary tree and linked list. We have given a linked list and we have to construct a binary tree, a complete binary tree. So complete, where it is? Yes, complete binary tree. What is complete binary tree? So if you search about this, a complete binary tree is left aligned binary tree. Means whenever you insert a new node, it will be placed on the left hand side and on the missing place. Like if we have to insert 7, 7 will have to insert on the 3 right. So this is the complete binary tree definition, and we have given this list and we have to construct a complete binary tree and we have to return this. So we have to first put 1, then 2, 3, then its child node 4 and 5. If we have this test case, then 5 is the head node, then 4, 3, then 2, 1. So let's jump into the approach. So if we have this list, the constraint is minimum it has one node. So we can build this one node as a head node. So we can say this is our head node, and for this we will use queue data structure. So and we will use BFS, which means breadth first search. So we have to insert nodes into the next level. This is the level, and the next node which we have to insert is this node. So we have put this node. Now head goes to the next position. Now we have this node. We will first insert this level nodes into the queue. So we have this node. First we pop out this node, and if head is pointing to a valid number, a valid node, then first we insert this node onto the left hand side. Then we increment our head, and this node will have to put in the right hand side 3, and we have made this node 2 and then 3. So head goes to next position. Now 4. First pop out this second node. Now 4. 4 will place here. Now we have made 4. Head moves to next value. Now 5. 5 moves to right hand side. Now head moves to next value. So we have put on the left hand side and on the right hand side. It's time for the next node. We pop out next node. Now we have 3. So 3. So first 6 node come into the left hand side. Then head moves to next value. Then 7. 7 moves to right hand side. Then moves to next value. Then we have to insert these nodes. So 4, 5, 6, 7. In this level we have these nodes. First we pop out this value 4, and we have a head pointing to 8. So we will from 8 here on the left hand side. Then head moves to next value. Then it is pointing to 9. Then 9 will place on the right hand side. Now head moves to null value. So we just return our head node. So it will return this tree. So the approach is very simple. First we made this head node. So first we create our head node. Actually we don't have to create it. We are given this node. So this tree is initially empty, and we have to create this node. So node is equal to new tree. First we create our tree with our initial value, head dot value or data. So we have made this one node. So it's time to fill the other values. So we will made a function head, and we have filled this one node. Now head moves to next value and start from the next value. So head goes to next value, and we have to pass this tree node, and at the end we have to return this head. So we will return our node. Now this fill function is important. How to made this fill function, how to create our tree? So let's find out. So for inserting a node, we have to know its parent node. So queue data structure will work as the parent. First we have only one, and head is pointing to this two node. So we have this node and head is pointing to a valid value. So we pop out this value, and if head is pointing to valid value, then we made a node first on the left hand side. So we have used this node, and head will move to next value, and we have to create on the right hand side this. So we have created this node, so we will put into our queue, and we have made this node, so we put into our queue. So that's all. Now head moves to next value. Let's find out how many nodes are there in this level. So this is called a level order traversal, and we have two nodes. So we will iterate in this order only two times, or you can implement this function without using level order traversal. So first we have 4. So for 4, we put first onto the left hand side 4, then head move to next value 5. So we have to put 5 here. We have used 2. Now head moves to next value. We have to pop out 3. So we have 3 node, and I missed insertion of 4 and 5. So we have to insert 4 and 5 whenever we made a new node. So now it's time for 3. So first 6 place on the left hand side. Now move to next value 7 place on to the right hand side. So we have implemented 3 left and 3 right. It's time for the next value. So 6 7, and now node is 7 4, sorry, and we have to insert 7. So 4, and we have used 7 here, and it moves to next value 8. So 8 will go here, and head goes to next value. 9 will go here, and it moves to next value. If there is a value here, then we have to place 10 here, then 12, 11 here, then 12 here, like this. So you got the idea. Let's jump into the coding part. So first we have node, and we have to create this tree. So we will pass the head dot next value because we have used the head value, and we have to pass the parent, and at the end we have to return our head node. So node is our tree. Initially it is null, and we have to create a node, and then we have to return our head node. So let's build the function bfs. It is called breadth first search. So in this we have a queue data structure. So first we implement queue data structure, and we put our head node. This is the parent node, and we run a loop while queue is not empty. So then we find out the size. This is called level traversal, and we traverse till size. We pop out our parent node, and if head is pointing to a valid value, we made a node first onto the left hand side, and head goes to next value. So then we have to insert this node parent dot left, because this will work as a parent when next level comes. Then again for right hand side, same thing for right hand side. So that's all, and this function will work fine. A click on the subscribe button is appreciated, and we have successfully submitted this question. Let's find out if without level or traversal can we solve this question. So I'm removing the level or traversal part. Let's run this. Yes, let's submitted this. And as you can see, we can solve this question without level or traversal also. And thank you all for watching this video. Let's wait for submission. And that's it. Thank you all for watching this video.